So hello everyone, today I'm going to solve this really special hard integral question from the hard daily integral of, this question is really hard because there's something called the dilogarithm function right here, Li2. So this requires using special derivative properties of polylogarithm and integration by parts. Are you guys ready for this? Well, let's just set this equals to I, right? The typical stuff. That's just I, or I, yeah, that's just I, right? Yeah, and then I'm going to take the derivative of this. What is the derivative of Li on nx? Well, that's just this one. So when I take the derivative of Li of nx, it's just Li of n minus 1 x over x. So then we can use integration by parts, right? Right, guys? Right? So we can use integration by parts here. We can let something called u, this thing up here, and then I'm going to differentiate that, which is just 2 Li 2x times Li x over x dx, like this. And then for dv, it's just this one, simple guys, just everyone should know this. And then the v is the integral of this, which is just the natural log of x, right? However, a more direct path exists by recognizing the derivative of Li 3x. Let's use a different substitution to exploit the power of the polylogarithm. Because we can let u, right, equals to Li 2x, and then du is just Li 1x over x, right? This is just with this one right here, or this is just negative of natural log of 1 minus x over x. It gets complicated quickly. Instead, let's use the power series definition, or known as identity, for the product of logarithms. So we can just use a general formula for this. So yeah guys, the general formula is this. I'm gonna write it out, it's gonna be pretty long. It's just the integral of 1 to 0 of, so this is the formula of Li of nx times Li of mx over x. It's just this long thing. Also guys, because we have n and m as the same, right? Because this is squared, so it's 2 and 2. We can just replace everything with 2. That means this is just the integral of, okay, let's just integration by parts. So we can let u of 2x, and then the differentiation of that is just Li 1 x over x, and then let dv as Li 2 of x over x. That means v is the integral of this, which is just with the old formula of this differentiation. We can, this is just Li 3 of x. Applying with the formula, we can know that this equals to this. Voila! So yeah, with our case, with this formula, we can just change it to this. Alright guys, I'm gonna delete everything now. So now let's evaluate what the integral is. So the boundary term at x equals to 1, that means Li 1, Li n of 1. That's just the Riemann zeta function. Or this guys. Okay guys, ignore my horrible handwriting, but this is just the Riemann zeta function. At x equals 0, like this, right? This is Li of n of 0, which is just 0. That means this one becomes the Riemann zeta function of 2 times the Riemann zeta function of 3. Somehow like this. So now in this one we have this. Then we have this one then, minus the integral of this. Well, using the identity, Li 1 equals to the negative of natural log of 1 minus x. Remember that guys? The integral just becomes this. The integral just becomes this. Using the standard identity of the integral of 1 to 0 of this thing, we can simplify this into n plus 1 times the Riemann zeta function of n plus 2 minus the sum of n, let's say a variable k equals to 1, of the Riemann zeta function k plus 1 times the Riemann zeta function of n plus 1 minus k. We can simplify the expression for the specific case Li 2x squared over. We can just simplify everything, we can just use calculations of combination of zeta value. All of that crap just simplifies to this. And then you guys know that the Riemann zeta function, if you guys know anything about Riemann zeta function, it's just which equals to this n minus 1. I should have explained this at the start of the video, but this is what basically the Riemann zeta function is: a complex function in number theory, combine numbers that add to infinity with the distribution of prime. For our specific case, this is very known as well. If we have the Riemann zeta function of 2, that's just pi squared over 6. That means our integral just becomes this. So our integral just becomes this, guys. This is actually a constant as well. So yeah guys, there you go. This is our final answer of this integral. Also this, when you put it in a calculator and actually evaluate it, this is just 0.8438 and it goes on. So yeah, this is just really simple. So yeah guys, thank you guys for watching this video. If you guys want to know the individual values of this, I'm gonna tell it here. This one is just 1.20 something, also known as the Apries constant, and this one is just 1.03 something like that. So this is our final answer anyways. So yeah guys, thank you guys for watching this video. I see you guys next time. Peace.